law if possible. So let's see what Ohm's law, very important. So let's see. I have sketched a diagram for Ohm's law. This is a closed circuit. This is the battery with the EMF E, electromagnetic force E, which provides the circuit a current I, ampere, and if there are 2 points between a resistance, any use of electric component, which you can consider a resistance here. So between these 2 points A and B is the potential differences is VA minus VB, potential difference, V is equal to VA minus VB. For this electromagnetic force, and here is a key for switch on and switch off. So the current flows from positive direction, from the positive side to the negative side, in clockwise direction. So now by Ohm's law we have E is directly proportional to the current in the circuit. So here, if we wish to replace this proportional relation with a constant, then we will have B is equal to Ki. So this proportional constant is written as in this way, Ri. Here this constant R is called resistance for this closed circuit. So R is called resistance for this circuit. So you know the units of potential difference is Ohm, volt, and I in SI units I is ampere, then R unit R unit will be Ohm, which is written in this way R. So we wish to study out the resistance. So in which points the resistance R depends on. So first is length of the wire, R depends on if this is L, then R is directly proportional to L. It means that if we take a longer length than a smaller length of wire, then we will have longer resistance for the circuit, and its second depends cross section of the wire, cross section area. So if we take the wire in this way, as a cylindric shape the wire is, so this area is called cross sectional area of the wire, which is A. This is A, and the length is L. So R depends on the cross section area. R is directly proportional, inversely proportional to the cross section area. Means if we have a more cross section area, then we have more resistance for the wire. So if we take these together, we will have R directly proportional to L by A. And if we wish to remove this proportional, then we will have a constant which we can write down. R is equal to rho multiply L by A. So from this we can calculate also rho. Rho is R multiply A by L. So in this way we can find out the units of rho also. Now I am going to discuss about Joule's law. You know that when current flows through a resistance R, current flows I for a time t seconds, then for here energy absorbs or energy generates, and with this heat absorbs or heat reveals. So this amount of heat which is produced for running a current in a resistance, if this is H, and if we have to work done for this is W. Then Joule's law says that the produced heat H is directly proportional to the current running in this circuit in the wire, square of the current flow in the wire. So the heat produced directly proportional to the square of the current flows, where R and T are constants. This is the first law. Second law, H is directly proportional to the resistance. If we have more resistance, then we will have more heat produced in the wire. For this case, we have current I and the time t are constants. And the third number is that H is directly proportional to the time taken for the current flow. So in this case, I, the current flows, and the resistance R are constants. So if we take two all together, we will have H is directly proportional to the I square R T. So then we can write down H is equal to J. This is the Joule's constant, I square R T. Also you know that for W is equal to GH, the work done. If this is W, then the heat produced is there also directly proportional. This will be H. The work done is equal to the heat produced. So we can write down this will be equal to J I square R T. So in SI units, both work and heat have same constants. They are constant Joule. So in SI, J, the Joule constant, have no units, but in CGS, you know that 1 Joule is equal to 10 to the power 7 R, and this will be Joule R, or Joule per calorie. These are the units in SI in CGS.